Hi, welcome to this tutorial on domains and ranges of functions. Now here I've got a simple function f of x equals 2x minus 1, and I've defined it for all values of x between minus 1 and 1 inclusive. Now the best way you can work with domains and ranges, I believe, is to have an appreciation of the graphs of the functions. Now, if I was to sketch the graph then of f of x, let's say it's y equals f of x, then I'm sketching this for values between minus 1 and 1. Now this kind of graph is of the form mx plus c, in other words, a straight line. So I only need to take the two endpoints to be able to sketch it. When x is minus 1, we get minus 3. 2 times minus 1 is minus 2, minus 1 is minus 3. So we can imagine that this point down here is the point where x is minus 1 and where y is minus 3. When we go to 1 and we put it through here, 2 times 1 is 2, minus 1 is 1. So we get a point up here where on the y-axis the y value is 1. So if we were to draw that graph, it would look something like that. Now, what do I mean by the domain and the range? Well, actually, the domain of the function is this part here. The domain is the values of x that you can put into the function and get an output. And every value of x between minus 1 and 1 inclusive can be put into this function. So we say that the domain is, in fact, all the x values between minus 1 and 1. We've got, if you like, a restricted domain. Now what about the range? Now the range is the values that come out when you put any of these values of x from minus 1 to 1 into the function. And you can clearly see from the graph that those values that come out go from minus 3 all the way up to 1. So we talk about the range as being all the values, and in this case they are f of x values, that is, f of x is between and includes minus 3 to 1. So I'd write it like that. Now that's all very well for this particular function, but suppose we just looked at the graph of f of x equals 2x minus 1. And what about if we didn't restrict the domain? What would happen then? Well, we've got our same graph, only this time we're not restricted to being between minus 1 and 1. We could in fact put any x values into here and we would get a much longer line. A line that goes something like this, but will go on forever and ever out in this direction for all values of x, and also go on forever and ever for all values of x in this direction. So the domain is written like this. The domain is all values of x that are real numbers. Okay? X is such that it is any real number. Now as for the range is all the values that you would get if you were to substitute any of these x values into the function. And these values would be all the corresponding y values. Now because this line carries on up here forever and ever and down here all the time, then we're going to include all the y values going out in this direction and going down in this direction. All the y values, all the f of x values, if you like, here. So in other words, the range is also f of x is any real number, written like that. Okay, well, let's try another example. Now if we were given the function g of x equals x squared and asked to find the domain and range, again I would want to draw a sketch. So if I label my axes x and y and I let y be g of x, which equals x squared, we should be familiar with this graph. It's a parabola, a U-shaped parabola. It's a graph that's going to look something like this, passing through the origin and going off like this. Now it would actually carry on forever and ever out in this direction and out in this direction, and it would continue to go upwards and outwards forever and ever. So when it comes to working out the domain for g of x would be all x values that go that way and go that way. In other words, x is any real number. However, when it comes to the range, we can see from the graph that the range extends from this lowest point here all the way upwards, because any of these values would give values on the y-axis that would keep going up like so. So we say that the range is g of x is greater than or equal to 0. Now suppose we restricted the domain. Suppose we had the same function, g of x equals x squared, but we restricted the domain to be x between -1 and 3. And let's suppose we can let x equal -1. So x is greater than or equal to -1 but less than 3. So what would the graph look like now? Well, if we just sketch it, okay, we have our axes, and let's put in -1 here and 3 here. So we would have part of this parabola. We would have it coming from here down through the origin and back up, something like that. So what would the values be when x is -1? Well, -1 when you square it is 1, so that would be 1 there on the y-axis. And when x is 3, 3 squared is 9, so that would be 9 up here. So what is the domain? Well, we know that the domain is essentially what we're given. That is, x is greater than or equal to -1 but less than 3. But what about the range? What is the range in this particular example? Well, it's not from 1 to 9. It's from the lowest point here, which is 0, all the way up to 9. These are the only y values that you can get when you put any value of x between -1 and 3. But in fact, because we're not putting 3 totally in to the function, you're never going to get 9. So when it comes to the range, it's g of x is greater than or equal to 0, because you can get that bottom value when you put 0 in. But because we're not allowed to put 3 in, we're going to get values which are less than 9. So that would be the range. And so hopefully you can start to see that by working from the graphs, you can calculate or see the domain and range. Now this is the first tutorial in this series on domain and ranges. In my next tutorial, I'll show you how we can handle other functions, such as square roots and reciprocal type functions.